In this video, I'm going to walk through some of the tasks I asked you to complete for problem set 2. So we'll be working in the Titanic data set, and we'll kind of go through these in order and check off most of them, and we might get sidetracked by a few things along the way. As I point out, perhaps on Canvas or somewhere, that there are often a lot of ways to do some of these tasks. So if you went about them different ways, that's good, and that's part of the process of learning Excel is to learn a bunch of different things. So if you found a new way to do it or a different way to do it, that's great, and perhaps I'll learn something as I sift through your answers as well. So I'm just going to give you sometimes just one or a couple different ways to tackle these. So the first thing I mentioned before even the tasks is that we have a large data set here. So there are 1,309, or there were 1,309 passengers on the Titanic. And so we're dealing with a lot of data relative to what we've been dealing with thus far. So figuring out a way to manage that data is going to be important. And so I remind you, you have the hide feature and freezing panes. So hiding data or hiding, in your data set. Remember, we can grab, drag, or select down and hide this data, and so it's going to collapse our data set. And obviously, we could do this with the last 1,200 of observations, and then we would have a more manageable data set. So that's one thing to think about, and you can always grab and unhide this data. Now, I do want to warn you that when you hide, especially rows, it hides everything in that row. So I had information here in my text box. It's still there. I just can't see it. And the same thing would be true for any visualizations that you've put in your data or in your worksheet. It also can make getting data onto, say, like a scatter plot. If you have a scatter plot and you hide some of the data, the default is that it hides that as well from your scatter plot. Now, there are ways to go around that, but just be mindful that when you start hiding, especially rows, it tends to make other things a little more difficult in Excel. But that can be one way to shorten up your data. Another thing, and probably more seen in practice, is, let's say, for instance, we're not going to deal with the number of siblings or spouses for a while, and we just want to get rid of it, but we don't want to delete that data. We might come back to it. Well, we can go ahead and just hide that variable and shorten up our data set horizontally. And so that's something that I see more typically done. And we can go ahead and unhide that again. The second thing I mentioned was freezing panes. So as we scroll around our data, we lose track of what the variable name is. Let me just zoom in a little bit. We lose track of the variable name unless we go ahead and let's go to View and Freeze Panes. Now, sometimes we'll do, you'll want to kind of keep the left-hand variable as well, or the left-hand, So if you had something like household number or name, and you were really focusing, and we could do it with name here, but if you were really focused in on employee name and you wanted to keep track of that as you scrolled to the side, you might want to keep kind of the left hand and or the first column and the top row. But here we're mainly just interested in making sure we know that, oh yes, I'm in the age or I'm in the child category and not the number of spouses. So freezing the pane or panes is often one of the first things you want to think about. And then lastly, I don't make mention of it here, but it can be helpful to format your data as a table. And that gives us sometimes some visual help, but also carries with it some of that sorting stuff that we talked about in a previous lecture. So that can be helpful. It also auto-fills along the way as well. So that can be of use. I think I'm going to keep it out of that because I'm sure some of you didn't. So let's work this direction. Okay, so the first real task I ask you is what percentage of passengers survived the trip? Now, later on, and when we build pivot tables, that'll probably just fall out of one of the pivot tables. But there are other ways we can tackle this. Now, typically, up until now, we've often done our descriptive statistics below the data, but we now have a very long data set. So if you found another area, that's fine. How do we get down to the bottom of our data? Well, we can use the control button to jump around our data set quickly. I'm going to just zoom out a little bit so you can see I'm with the arrow keys I can move around. Now if I hold control and I hit the arrow key, it jumps me to the end of the data. And I can hold control and hit the other arrow key and jump back and forth. I can jump up. Now I can also jump down, and that's going to be the helpful trick. I hold control and I hit down, and all of a sudden I'm at the bottom of my data. So you don't have to sit and scroll and scroll and scroll. You can get used to using the control key. Now when I use control up here, it's going to bring me to the top row, but notice we're frozen, so that top row is visible, so it hasn't actually updated my screen. So now without holding control, if I hit down, I'll be in the second. Okay, so then it's going to reframe my screen. So I'm going to hold control down, come down here. I'm in the bottom of my data, and so now I can, put or be calculating data or things in a kind of typical place. So you can do that. Maybe I will jump up here though. And let's just build some of that stuff over here so we can see our tasks at the same time. So I want to know the percent of passengers that survived the trip. So a few different ways you could do this, right? And so I want to know how many survived. And so because it's a dummy variable, right? It's a 1 or a 0. I can simply do a sum of survived. And that's going to tell me that 500 people survived. I'm going to go ahead and hide this. And in fact, I probably don't really care too much about the name of the people right now. Apologize to them. So we can just shorten that up and maybe hide a little bit more of that. Okay, so we know 500 people survived. We can also, I think we know that it's 1309. We can do a count variable, and again, just count up survived, and that's going to count how many cells contain a number. So we have 1309, and so we can simply say, 509 divided by 1309, and 38% survived. Now, we're also working in a dummy variable, and so if we take a moment and think about this, if you survive, you get a 1, and if you don't survive, you get a 0. And so it turns out that because the survived count as a full 1 and the died count as a 0, we can take an average of that, and we're going to get the same result. Right? And this leads us into our probability discussions. We're going to use the same concept. And so, so if we just take an average, that 38% are 1s, and so they've survived. And again, we'll see that we can find specifically these values right along in a pivot table as well. So the next thing I ask you to do is to build a histogram of age. Now, when we turn to building a histogram, and I mentioned we can build it either with the data analysis or build it by hand. Either way, we need to determine the bins that we're going to use. And so just going to give us a little age header, and what's the max? The max of age. I'm going to just scroll over here. Now I'm able to select this whole column because I know that I don't have data below, the end of our 1309. So you do want to be careful if you have descriptive statistics down there to not select the whole column. So we have an 80-year-old. I do know that we have, children stretching down near 0. So we'll need to go from basically 0 to 80. But it might be curious, or you might be curious. It looks like we have a 2-month-old, right? 1/6 of a year. And so, so we're going to need to find data that stretches from 0 to 80. Now, what is our rule of thumb? 2 to the k greater than n, where n is 1309. And so we need 2 to the k to be greater than 1309. And so if we want to kind of test ourselves or just use Excel to help us out, 2 to the 10th is probably going to get us close, right? Okay, so that's 1024, so 2 to the 10th. So 2 to the 11th is going to be, what, 2048. Okay, so our rule of thumb says 11 bins. And we could go ahead with that. I think I would just I would deviate from that, or start with a deviation. I think the natural kind of 10-year breaks is gonna feel more comfortable, and be more visible. So let's just go ahead with that. Again, if you did this a different way, that's fine. But knowing that I need to get to 80, it's gonna, I think, be a more visually appealing way. Now I've kind of fudged a little bit. I'm going to go 0 to 10 here, knowing that there's, I guess that's still 10 years. Well, the 10-year-olds probably get counted in this, so this is really 11. Anyway, I think it'll be okay. So next, we can again build this with either a count function or frequencies, or we can use our data analysis toolpack. Okay, so we're gonna go ahead and use the data analysis toolpack. If you still if you're forgetting where to get this, check out, I think the first place I have it is in the histogram video, but it's in a few lectures as well. So we can pull up the data analysis toolpack. We're gonna do a histogram, and in here I'm going to grab my data. So this is, what are we doing? We're doing age. Now, let's go ahead and just, we're going to type this in. And this is going to, oops, E1310. Now I want to warn you that this is going to create an error. And we're going to walk through that, and you're going to have to bear with me as I remember exactly the best way to fix it. This is, I emailed this out and told you to check out the lecture about this, because this brings up a pretty interesting result. So we get an error that there's an input range contains non-numeric data. Okay, and so our input range, right, if we think back, our input range is this E2 to E1310. And so it's telling us that there's non-numeric data here. But as we look through age, we see a bunch of numbers. And really all we see is numbers and some missing data. Okay, and so this brings up the concept of missing data in our data set. And how we get data into Excel is sometimes important. And so a lot of times missing data is treated as just non-existent. Sometimes you'll see missing data as a period. So you might have a data set that looks like this, and there's a little dot there. And that's seen not as much in Excel, but in other programs that's used. You may see data entered in, or you might see a value of something like 999 coded, and that means missing data, or that there was no answer. And so you might get data with, so for instance, age here. We could have seen data says this, but then this value is here, 999 or 9999 or 9998. And so in those times, it's often helpful to look at the code book and see what the data entry people intended. And so what's happening here is that this is not actually, so actually let me, the best way to maybe see this is let's actually go ahead and make this into a table. I think it'll be I think this is what I do in the lecture too. So when we go, right, one of the benefits of a table is I can quickly view only people that died. Okay, so when I go into age to do something like that, I see all of these different ages, a lot of different ages we have. Down here at the bottom, I have blanks. I have something that's listed as blanks. It's not a blank, but it is, that's a weird way to say that, but it is treating it as though it is kind of you can think of it as the character or the letters spelling out blanks or something like that, right? So it's not nothing, and it's not a number. And so Excel is having an issue when it's trying to, or the data analysis toolpack's having an issue when it's trying to put everything into a numbered bin. It's having trouble with this blanks concept. Okay, so there are some ways around it. We could alter the way that our data is stored in terms of what the missing data is treated as. That's a little more cumbersome in Excel than it is in other programs. But we could do that. The simplest solution for us, however, is to simply just not include that data in our histogram. And so to do that, what we're going to do is go ahead and sort this data. And you don't need to be in a table to do this. Let me just... There we go. I was just going to get back out of the table. So we're going to go ahead and sort our data. I'm just going to grab all the data, go up to data and sort. If you haven't grabbed the data, it'll still yell at you. So that's okay. To grab the data, I should say. So we're going to sort by age. And I'm going to do, let's just do smallest to largest. And we see all the babies down here. Let's see. The 2-month-old survived, but what is that, 4-month-old? That's, the 4-month-old did not. Anyway, not exactly what we're focused on here. So if we jump down to the bottom, here we have all of those missing data that, number one, it's treating it not as a blank, and in fact, it's treating it as a large, or it's counting it as larger than the numbers. And you can see that this issue would remain if we're dealing with a number of these different variables. So we have missing data around our data set. So our solution here, we can see we have 1,047 that have an age, or sorry, 1,046. So now if we go back and redo our histogram, and let's go to 1,047. Okay, and there's no more errors. There's always a chance. And so here we have our histogram of age. Get rid of that. We can do some of this cleaning up, right? We want to take that gap with the way, because we do have histogram where they're bumping into each other. We'd probably want to, I always like a line. I don't know why. My eyes are getting old. Very extreme line, but we could do something like that. We'd also probably want to kind of indicate that this is 0 to 10 or something like that, to make sure we're understanding what's in each of these bins. Okay, this is gonna, yeah. So anytime you put anything that Excel can kind of think is a date, it will go with that and make it a date. So that's annoying. Yeah. So there are ways around that, and Excel's trying to be helpful. That's what I would say. But they often fail. Okay, so yeah, so anyway, this is a quick histogram of age. Might want to say age of Titanic passengers. And you could, so format cells, you can take this into I think we want is just to leave it as a text. 11 to 20 should, yeah, okay. So if you put it as a text, it will no longer think it's November 20th. And you could finish that out. Okay, so that's how we would build a histogram. Let me get out of that. For age. If we want to continue our discussion of age, we'd want to know the mean of age and the standard deviation of age. Again, we could put that down on the bottom, and hopefully yours is a little cleaner than my randomness here. We can do the mean of age, right, and the standard deviation. Now, which standard deviation do we want here? We have the population and the sample. This is a population of Titanic passengers, right? This is not a random selection of the passengers. And so again, we grab age. I meant that to be there. And so we now know that there's a mean of just under 30 years and a standard deviation of 14.4. And we have a nice histogram of that as well. So we kind of have a nice way to summarize what's going on in the age of our passengers. We can see visually it stretches from down near 0 to 80. Now we probably would want to include that minimum, right? It's kind of a eye-catching thing that there was a 2-month-old on the boat, and so just yeah, something you don't want to. That's a case where expressing the minimum might help your readers, especially if you're trying to tug at heartstrings or something. Okay, so next, I think the next thing I ask you about is a pie chart of class. So again, a number of different ways we can tackle this. The most straightforward, we'll need to build a frequency table, right? So if we just try to grab the data and put a pie chart in from our column of data, it'll not work. So we need a frequency table, and so for class, we know that we have first, second, and third class. Okay, and we need the frequency. And so here we can return to just the count if. Right, and so we can do within the range, and so we'll go over and we can just grab the class. Okay, and we want to know if it equals, and here we'll just choose that, and we now know that we have 323 and so on for second and third class. Again, this can be done through a pivot table, so you can find that information. But now that we have this simple frequency table, we can go ahead and insert a pie chart. And there it is. Okay, so now we're going to need to clean up a little bit, right? This pie chart doesn't really tell us too much. We can do passengers on Titanic by class. Ticket class. And okay, so what do we have going on here? So we have a little legend down here if our eyes can squint hard enough. I don't know why Excel's defaults are still minuscule size print. Let me just zoom in a little bit anyway. So a couple things, quick things that we can do. We can add We can add data labels, and that gives us these the labels inside, right? As opposed to, we still have the legend here. We can take that off, and in fact, we may want to just do that. If I click and drag these out, sometimes that's more visually appealing. We can rename these, so I probably would want to call this just first class instead of just 1. I can also increase the font size, and always a good call with Excel. Second class. You can find ways to change the color scheme as well. Let's just get some basics done here though, and let's jump this up to 14 as well. And so now we can see a little bit better. If you have, so I tend to, actually this brought me right to it. But in the formatting, if you're on one of these values, we can change the angle of the first slice. So I think it looks better. We can put it anywhere we want, but as we've talked about, or whoops, that's going to be confusing. Wonder what happens when you do. Oh, it just converts it for you. Yeah, starting with the large value, or the largest group on the kind of reading like a clock from 12 o'clock is often visually helpful. Although here, I would like these to be switched. I don't know what happened there. So anyway, there are ways to reorder. I thought that was gonna. I don't love this, but I would have to Google up exactly how to flip that last order. I think I also could just reorder them in my frequency table. But anyway, a lot of things you can do. You can always, if you can dream it up, there's probably some way to do it. But yeah, so that's a simple pie chart. Let's go back to what else did I ask? Okay, so here we might want to build a new variable. Okay, we've done this before. We've built, again, this is going to be a dummy variable, right? We have 1 for women or child, and 0 for neither. And the reason we might want to do this, right, there's the classic women and children first is, you know, if you've watched the movie, that was kind of a standard practice, or at least theoretically a standard practice, and as you see in the movie, not always adhered to, especially you can finagle your way on. Anyway, but we might want to be curious about women and children and think about if they did have a better or worse chance of survival. So to do that, we want to combine. We have women, or we have female, and we have children. And so combining this into one kind of concept is going to be helpful. Now, there are a lot of ways we could do this in a couple kind of main ways. Let me just clean up. I know I'm not staying very organized, so I apologize for that. Whoa. Control Z, your favorite friend in Excel. It's going to yell at me. Okay. So I'm going to just create a little space here, actually. Let's just insert some new places. So how do we get women and children into one variable? So we have a variable to tell us if that person is a child, and we have one to know if they're a female. And so to combine those, in some sense, what we're really looking for is female plus child. And so we have something like this, right? So this is child plus female. But we have a little issue here where we now have 2s. I must have this sorted. Oh, I have it sorted by age. Well, that's handy for this experiment. Yeah, so all of these up top are going to be, let's I'll redo that here in a second. I'm going to just sort my data so we can see what's happening with zeros. So let me just grab data, sort, and we can sort back by name. Okay, so here, just so we can see what happens when they're not, we can do something like this, but as we saw, there will be some 2s, right? And so the 2s are tricky. We don't actually want a 2 in our dummy variable. And so we could do another step. So this would, and we could say equals if, let's say if this if this is greater than 0, then 1, and if not, a 0. Right? And so this is going to fix our 2 issue and bring it as a 1, right? So we're basically just saying if any of these values here are greater than 0, then they become a 1. Now we can go ahead and just put that into one step. Right? Let me make sure I have space here. So women and children. Okay, and we want this. Let's do it in one step. So if child plus female. Now I'm gonna try to. So I want to add these together, and then compare that to 0. Right. So I had to kind of bracket that so we were adding first. So add these two together, compare it to 0, and if that's greater than 0, then put a 1, and then if not, put a 0. Okay, so we're smushing together this kind of check of greater than or equal to with the addition. So we can kind of do it in one big step. And this is going to give us what we've built previously. Okay, so this should match this second one. So I'm going to go ahead and delete these. And so, yeah, so again, all we're doing here is we're adding female and child, the 2 together, but while we're doing it, we are double checking that is, or we're checking that that's greater than 0. And that's that logical test. So if it is greater than 0, we put in a 1, and if not, it's a 0. Okay, and we'll just drag it down. And there we have it. So we might want to just quickly count. Oh, that's just counting up. What did I do before? Oh, we could do sum. Sorry. It's going to be the easiest. We have 523 women or children. Okay. So next, the last kind of part we're going to deal with is inserting pivot tables, and so how we can kind of start to examine the relationship between these variables with pivot tables. Okay, so I want to let's just see. We're going to talk about women and children and survived. Okay, seeing if there's a better chance of survival if they maybe, we could even take this and look at boats and whatnot, but the idea was they may have gotten on the boats earlier. We're also going to look at class and survived. Yeah, so let's just insert a pivot table. That's not what I wanted. So insert pivot table. And I'm going to put it in a new worksheet. So, because we have so much going on that table, or on that worksheet. So, yeah, and we wanted to look at survived and women and children. Okay, and then we need to, again, put in some type of something that's going to count up. Okay, so when I bring in kind of a character, or non-numeric, it's often going to default to the counter name, so that's easiest. Okay, I'm going to come up and I'm just going to go up to design, and I think, yeah. So if I made this into outline form, it just gives you that survived and women and children a little cleaner. So here we can see. So remember, this brings with us those original. There's 500 survived out of the 1309. We knew that there were 523 women and children out of the 1309, and so we can see, we can find a lot of this information that we were working on before. I'm just going to zoom in because we're only focused on this. So now we can start to talk about some of those kind of conditional probabilities, or examine if we think that there's a relationship here. So we can see that. So the we can. This is really adult men, right? Or over 15 or older. So it looks like, so there were 809 deaths, 654 were adult men. And so there definitely does seem to be some relationship here. So for men, most of them died, and for women and children, most of them survived, or greater than half of them survived. We could even look at, again, so 5. Let's do 368 divided by 523, right? So what's the likelihood? Let's just do that out of this divided by that. So 70% of women survived. Women and children survived. Whereas only 16% of men survived, adult men. And so obviously there's something, so there's a pretty strong relationship here between survivability and whether you fall into the adult men or women and children. And so that might lead us down a path of examining this more closely. Now, as we do that, one thing we would likely check out is this relationship between class and survived. So we could change this pivot table, but let me just insert a new pivot table. Oops. Let's see if that's gonna work. Great. Okay, so we can do this quickly the same. Let's put name down there. We wanted to look at survived, and we wanted to look at class. Okay. Oh, I have blank here because I clicked the whole column, so this counted everything below it. So that's kind of annoying. There's probably a way to quickly remove that, but we have all the information here. So again, do we have a relationship between your class and your survivability? And we may want to. We could look up percentages here. We can also change these and show values as percent of, say, column total. We still have a blank one there too. So, but for first class passengers, 58% died. Second class 67, and third class 61. So there's obviously a relationship between survivability, and here's that 38 overall. The 38% survived. There's a relationship between your class and your survivability as well. And so both of these results would lead us to examine this more fully. And what I want to caution us about is that there might also be a connection between, say, women and children and your class, right? And so we might want to look at that pivot table, because maybe the driving force isn't class, maybe it's women and children, or maybe vice versa. And so what I'm really getting at is that we don't have a causal relationship yet. We wouldn't necessarily be able to say, being a woman or a child made it that you were more likely to survive. You were more likely to survive, but it might have not been the causal mechanism there. So towards the end of the semester, we'll get into how can we maybe piece out some of this causal relationship, or what type of conditions would have to be true for us to say causal statements more generally. But these pivot tables can at least lead us down interesting kind of thought experiments and directions to dig into our data more fully. So and then I think the last one, how many children were unaccompanied? Again, there are a number of ways we could do this. We could build a new variable, but as we've just seen, we could insert a pivot table. Let's just change this one. So let's get rid of that. Let's get rid of this. Let's look at children. Let's look at number of parents. This already exists. I don't know what I just did. Can't tell you what that error was. But now I need to zoom out. We got a lot going on because some people have 9 parents on board. Well, they don't probably have 9 parents, but they do have 9 children on board. So, but what we're interested in here is, are you a child and are you unaccompanied? Right. So we have children here. We have we had 107 children. Some of them, none of them had children on board, so they probably don't have 3, 4, 5, etc. But a lot of them had 44 of them had 2 parents, 53 had 1 parent, but 10 of them had 0 parents with. So we have 10 unaccompanied minors. And so that's probably the quickest way to get to that information. Again, many ways you could do it. So hopefully this gives you some more insight now that you've gotten your hands wet with this data and struggled around with it. Perhaps this will be more useful to go back and look at. So yeah, and as always, if you have any questions, feel free to reach out and let me know.